We have consequences too. Okay, so let's go over this. Now I want to remind you guys that you have done this in visual. These are, let's just go over, you guys have the sheet in front of you, right? The sheet that you have in front of you, the first sheet that looks like this, chapter 5 in there. Here's what I have. I have 3 poles. These blue things are 3 poles. Each pole is a 10-foot pole. It could be 30 or 40. I'm just using a 10-foot pole. Each pole, I have a 70-watt, I think it's metal halide fixture that we're using. 70-watt metal halide fixture mounted at the top of the pole, each one of them. The poles are placed 10 feet apart, 10 feet apart. So that ratio between mounting to spacing is 1:1. You guys remember last when we talked about chapter 4, the spacing between mounting height and 1:1 or 2:1 and so forth. Okay, so there is a circumstances. I have light fixture 1, 2, 3, and I have point A, point B, and point C. And my job, Andrew, is to find use the point-to-point method. It's called point-to-point method to calculate the foot candle at point A from fixture 1, fixture 2, and fixture 3, at point P from fixture 1, 2, and 3, and at point C from fixture 1, 2, and 3. Everybody understand what we're doing? When we did chapter 4, if you guys remember, the ones who were here, we did one pole, and we did 3 points from one pole, one fixture. This time we have multiple poles, multiple contributions from different fixtures, basically. Okay? The ones who were here, as I said, when we did the 4, we only used one of these at multiple points. Now we have 3 poles, 3 fixtures, and we need to find the foot candle at 3 locations. Now, when you guys did the parking lot with me and you grabbed that photometric curves, right? And you were laying them out at the top of each other, that's exactly what this is doing. So at point A, fixture 1 is going to have some contribution, and 2 and 3, so the total foot candle at point A will be added together. What A is going to shoot, what 1, 2, and 3 are going to shoot at this point A will be all added together. Can I have thumbs up, Chad? We understand what the layout is? Cool. Okay, for those of you who are here too, we thought when you do point-to-point calculation, here's the formula. Thanks God there's formulas, right? We go foot candle. This is not the average foot candle. This is the point foot candle. One location foot candle, not average. Foot candle, there's 2, if you guys remember, just refresh your mind, there are 2 ways of doing foot candle calculation by hand. One way is the average, and we did calculation on the average when we did chapter 4, when we took a space with 2x4s, and we calculated how many fixtures 2x4 based on the average foot candle that we need to maintain, right? And we spaced them. You guys remember that? We spaced them appropriately. That's the average. The average is the poor man's job. The rich man's job is point to point. That's what visual does. You guys remember these brown dots that you did? That's called point to point calculation. Every point in visual was 2 by 2 feet. At the corner of every 2 by 2 feet square, it will do a calculation, right? Through the whole calculation zone. That's what we call the calculation zone. This method is actually that calculation zone that you did at 3 points instead of tons of points that visual did. Imagine if you want to do that one at every single point in your room. Can you guys appreciate visual now and the softwares that we have? Okay, here's a formula. This is the guard factor. GF is, they call it guard factor. I'll talk about guard factor in a second. CP is candela power. That's a lumens coming out of fixture. And cosine Q or theta is the angle with the vertical. Can you guys see where here's a Q3, here's a Q1, a Q1. So these are the Q. The Q is the angle that the ray is making with the vertical. Cube the cosine divided by the mounting height squared. Any question about the formula? Now, what the heck is a guard factor? Guard factor, I call it guard factor given 0.88 given. Guard factor is when they put the fixture to protect it from insects and so forth, they have a guard on it, right? A shield, a cover that will protect it from the insects getting in. The problem with this guard factor, guys, what does it do when you put a shield in front of the lamp? It cuts on the light. Thank you, Joe. It cuts on the light. So you have to accommodate for that one. Now, the other factor that we're missing here is also the light loss factor and all this good stuff. Assume all these are lump sum into the guard factor. So they just this is the only factor that you have to accommodate for in this example. Okay? Any question, guys, about the formula? Can I have thumbs up, Chad? We fully understand what the formula is. On the test, please bring the formula with you. If you memorize it, that will be great. If you don't memorize it, have it with you. Okay. So this is the formula. This guard factor is given based on the type of the guard that you put in front of the lamp for the fixture. All this information is given to you. What required is to find the foot candle at point A, point B, point C, separately from all the three fixtures. Thumbs up? Let's go do it. So if you understand what circumstances is, then doing it, guys, becomes a piece of cake. Doing it becomes a piece of cake. Okay. The first thing I would like guys to do is calculation at point B. Okay? Everybody knows where point B goes here? Point B, right in the middle. I'm doing calculation at point B, right in the middle. The point immediately under the lighting fixture, guys, is called nadir point, which is the zero. If it's a zero angle, they call it the nadir point. Not Rolf Nader, but nadir point. I think the guy who invented it or discovered it. That point right underneath it is called the nadir point from that fixture. From this fixture, from fixture 3, the contribution from fixture 3 at C makes a 0 degree, right? That's also called the nadir point that's coming from 3 to C, nadir point that's coming from 2 to B, nadir point that's coming from 1 to A. But the one that's coming from 2 to A, it's not a nadir point because it's not directly underneath it. Cool? You're going to hear the nadir point 0 fixture. Okay, let's go ahead and calculate at point B. Now, Adam, my friend, at point B, how many contribution we're going to have? 3 contribution, right? 1, from 2, and from 3 fixtures. Can I have thumbs up, chat? So 3 calculation we're going to do. 3 calculation. And then we're going to do it at A, and we're going to do it at C. Why did I pick B in the middle? Because P is the most calculation that relate to, you're going to see that P is there's a lot symmetrical. Okay, so we got that one. Everybody can see where the angles are. Q1 here. There's also Q here, and the angle here. And there's also the angle that this makes from A to B. We'll talk about the angles in a second. So contribution calculation at point P. From fixture 2 at point P. What's the angle from fixture 2 at point P? Anybody can guess what the angle? From 2 to B. Big fat 0, right? So from this will be your big fat 0. Then what I would like you guys please go to, from this, go to Fig 5.3 in your book. You have to have a 5.3 in your book. 5.3, page 50. Page 50. Could you please go there? There's a graphic. Without this graphic, good luck finding it. Here's the graphic that you're looking at. Can you guys see it right here? That graphic. We used this graphic before, guys, when we did chapter 4. Page 50, 5.3, right in here. Okay, now I want to go to my favorite friend, Jeff, and ask him, Jeff, based on this table, at point 0, what's the foot candela power? Do you have it? At point 0. Angle 0, candela power CP, 949. So the candela power is 949. Any question, guys, about this? Any question about this? 949. Everybody knows how to use this table? This table have an angle and candela power. Based on the angle that you make with the vertical, and the angle will decide which point you do the calculation on. Based on this angle, it will give you certain candela power. It will give you certain candela power. Okay, I have 949 candela power, which is lumens. Cool. Then Then all what you have to do now, you guys, this is done in front of you. You take the foot candle, multiply by the guard factor. This is the derating factor times 949 times cosine 0, which is 1 cubic, divide by the square of the height of the fixture. That will give you, anybody came up with something? 8.35 foot candle. So right at point B from fixture 2, I'm going to have 8.35 foot candle. Any question, guys, about this? See how easy that? First, you need to find the angle. From the angle, you find the candela power. Then you plug the angle and the candela power in the formula, and you do the math. The math is piece of cake, right? Any comments, guys? Any questions? Okay, since you guys don't have comments or questions, let's go to, so this is at point B from fixture 2. Now I need to go from fixture 1, here's 1, at point B. From fixture 1, we're still calculating for point B. At point B, do you guys see the angle Q1 here? Okay, I have my angle Q1, so Q1, what's the angle? We need to find, can you guys see that one? From here to here, I need to find this angle. You guys remember the tan and the cosine? This is where you're going to use the tan and the cosine. So where are we here? So I need to find Q1. Tan Q1, to find Q1, you have to go use trig. You're going to use trig, tan. You guys remember what the tan of this picture is? The opposite over adjacent? Not opposite over adjacent is opposite over adjacent. The sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. You guys remember the sine, cosine rules, right? We'll review them. So if you want to find the sine of this angle, the sine is the opposite 10 over the adjacent, which is this distance. I mean, the sine, the opposite over the hypotenuse here. The cosine will be the adjacent over hypotenuse. The tan, so why wouldn't I use the sine and the cosine? Because do I know the hypotenuse here? I have no idea what the distance from here to here. I care less, as a matter of fact. So I picked the tan because the tan is the easy to find. The tan is opposite over adjacent. Do I know what the opposite is? Yes, Chad, it's 10. Do I know what the adjacent is? Yes, Chad, it's 10. Cool? So tan Q1, everybody knows why I use tan, not sine, not cosine, because tan is the one that gives me, cosine and sine would not give me, I don't know what this red line is. I can't find it from Pythagorean theory, right? Square the 10, add them up, take the square root of them, that will give you this value, right? That's a right angle rectangle rules, Pythagorean theory. Okay, tan Q, what's tan Q? Tan Q equals 10 over 10. Everybody understand that? 10 over 10. What's 10 over 10, gentlemen? We have 10 over 10 equal 1. So tan Q is 1. Then you need to go and find tan inverse. Tan inverse 1. Everybody knows what a tan inverse 1? Tan inverse 1, what is the angle that has a tan of 1? You guys have, everybody did trig, kind of? So we understand what tan, an angle, and tan inverse. Tan inverse an angle is the reverse function of the angle.
45.
Okay, absolutely. So tan inverse of an angle, so then tan inverse of the angle is going to be 45 degrees. That's it. Now, how do you use tan inverse in your calculator? It depends which calculator do you have. Before I go ahead, guys, for the test on next week, please, I have Casio here. I'm used to it, but you guys have probably Texas Instrument. Please know how to use the tan inverse and the tan in your calculator. Okay? Get used to finding the tan and the tan inverse. Tan is easy. You put the angle, and in Casio, at least, you put the angle, then you hit tan. I think in Texas, do you put the tan first? I can't remember. So every calculator works differently. Some of them you put the cosine and then the angle. Others you put the angle, then the cosine. Tan inverse, the same thing. You put the tan, the number, and then you hit inverse tan, and it will get you the angle. Can I have thumbs up, Chad? We fully understand how to find the tan and the tan inverse. Yes? Let's start with Kerry. You guys there? Are you good? Okay. Andrew? Good with the tan? Okay. Darren? Good. Aaron? Cool. You guys, Joe? Good? Okay. Good, good. All right. So everybody knows the tan. I don't need to spend time. Okay. Tan 45. So that's it. Now I know the angle. Now I know the angle. Can I find the foot candle and plug in this to formula and find the calculation? Piece of cake. Really, the difference between from fixture 2 to B, the difference between fixture 2 to B and fixture 1 to B is just finding the angle. If I find the angle, it's piece of cake. Should I move on? Yes? No? Cool? Okay. So let's go down. So we got our tan inverse. Okay, now that we know the angle that we have is, I'm going to give you a few seconds to write, guys. The angle is 45 degrees. I want you guys to go to Fig 5.3, page 50. And from there, who's my favorite guy who's going to get 10 out of 10 in participation and tell me what the foot candle is? How much?
3.23.
Say it again.
3.23.
The foot, not the foot candle, the candela power. 1039. Here's my candela power. By the way, the candela power is lumens. The candela power, lumens. These are lumens. 3,000 lumens coming out of this bulb. These are the lumens. So at this angle, the fixture will be able to deliver a 1,059 lumens at this location. Does that make sense, guys, what this is? At this angle, we should be able to deliver this amount of lumens at this angle. Cool. So the lumens, guys, is a function of the angle, right? The function of the angle. You can see, Darren, if you look at the graphic, you can see at 0, you have a foot candle, a low, then it keeps going up, 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 up as you go forward to 45, and then start going down again, right? Can you guys see the curve, how it goes down again? So the best foot candle that you can get out of the fixture is at angle 35. Can you guys see that? The best foot candle, the lumens at 35. Is that the best lumens? Okay. Okay, let's go do the calculation, will ya? So I'm going to go do my calc. My foot candle would be 0.88 multiply this. The candela power is 1039 times the cosine 45 to the power 3. Cool. And then I'm going to divide all this by 10 raised to the power 2. Everybody knows why 10 raised to the power 2, the height of the fixture is 10. If you guys did the math, this will give you equal 7.33 foot candle. So at this point, I get 7.33 foot candle. 7.33 foot candle. Andrew, I want you to see, even though you got more lumens, can you guys see that? Even though you guys got more lumens at 45, the nadir point, at the nadir point, you get more lights because of the cosine of the angle. Does that make sense? Right underneath the fixture will get you more lights, more foot candle. Even though you got more lumens, but that lumens will disappear because it's further distance. Any comments, any questions? Any comments, any questions? Okay, now let's go from fixture 3 at point B. This, I call this is symmetrical. You guys are familiar with symmetrical? So any question about from point 1 to, from fixture 1 at point B? A piece of cake. Now let me take you back, gentlemen, to the graphic. From 1 at B, symmetrical, to 2 to 3 at B. Can you guys see that? Do you see the symmetrical? Do I need to do the calculation again? No, because the distance between everything is the same. Can you guys see that everything is same? The height of the fixture is same. The width is the same. Same fixture, same distance. everything is the same, and it's a symmetrical triangles, do I need to do the calculation? If you do the calculation, would you end up with the same answer? Yes. Okay, can everybody see the symmetrical between 1 to B and 3 to B? Aaron, does it make sense? Coming from here all the way, from here all the way, the same distance between them, the same height, same distance, same height, same angle, same fixture, same fixture. Here's where somebody can screw you up. They go put this height at 25 feet. If you have the height at 25 feet and this is at 10, now that's what I call a stupid design. You know, you can't use a symmetrical then. The nice thing about the using it by hand in the past, guys, is they use symmetrical. Everything is the same. So you do a few calculation and then everything else is symmetrical, the same calculation. Okay, I need thumbs up that everybody understands symmetrical before we move on. Cool? Okay. Let's go back. I don't want to go back to here. I'm going to go back into fast. Okay, so because of symmetrical, then this will be the same value, right? So that will be because I'm at 8 point. So we got this one. Why did I put at angle? It's not 7. Did you guys come up 7?
I got 3.2.
That's what I mean. I think I just read my handwriting wrong. 3.23. Did you guys come up 3.23? Okay, thank you. That's what I thought. It's 3.23. 3.23. Okay? This is just a calculation. Then when you come over here, this will be also 3.23 because of what? Symmetrical. Can I have thumbs up, Chad? We got it? Cool. Then the total foot candle for that whole fixture, the total foot candle at point B from all the fixtures together, you just add them up. We don't average here. This is not averaging. This is just adding them up, right? So that will be, when you guys add them up, that will be, let's start with 3.3. Let's use, 3.23 plus 8.35 plus 3.23, and that will give me a healthy 14.87 at point B. Do you guys see that? Everybody can see that? Is this the average? No. This is not an average. This is at that particular, it's going to have contribution from 3 fixtures. Now, Zach, if I have 3 fixtures, if I have 20 fixtures, would it be different calculation? No. I mean, in terms of the process will be the same. It's just more calculations. So then you have to do 20 calculation from 20 fixtures at point B and add them up. Did you guys get that? If you have 20 fixtures and you need to find the contribution from, for example, I have, how many fixtures are on? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right at the top of Zach's head, if I will do a calculation right now, I will do calculation from every one of these 6 fixtures and then add them up. Can you guys see that? Everybody can see that point? We're done. Okay, so 14.87 is your foot candle. 14.87 is your foot candle. Any comments, any questions? This will be on the test on Wednesday next week. Aaron, my friend, good, bad, ugly? Good? Okay. 1487. Did they say 81? Did anybody came up with, did they add up to 81?
3, 3, and 5 adds up to 1.
Anybody verify this, will you? 81? Okay, well, what 81? I think I got them because of approximation, probably. Okay, 81. 323, 835, 323. I bet you because I kept the, when we added them, we kept the others. So 14 on the test, 87 or 81, you know, it will be 1. So just FYI, because there's approximation. So we can tell that this is 15 foot candle, right? Any question, guys? Shall we go to point, which point are we going to go? Point A. So let me just summarize here. So we did all the calculation at point B. Now we're going to go to point A and do the same calculation. Before I go to point A and do the same calculation, I want you guys to tell me, do you guys expect the calculation from 1 to A to be exactly like the calculation from 2 to B? It's another point. The same, everything is the same. So I don't have to do one calculation is off. The second thing, see how the symmetrical becomes a big deal? The second thing, you guys expect the calculation from 2 to A is the same as from 1 to B because of the symmetrical? Yep, everything is the same. From 2 to A is the same as from 1 to B. So that calculation is done for you. Symmetrical, right? The only calculation that I need to do is the contribution from fixture 3 all the way to fixture A. Fixture 3 all the way to fixture A. Because the distance right now is what? Double. Can I have thumbs up, Chad? We got that? Am I going too simple in that? Should I go faster or? Okay. Okay, so let's go ahead and do them, guys. So we're going to go to, everybody understand why the symmetrical in there? Okay, let's go here. All right, so foot candle at point A. Foot candle from at point A. From fixture 1 at point A, the angle is, this one was equal what? 0. You guys remember that's an 8 point, right underneath it. Foot candle at point A. The first calculation, foot candle from fixture 1 at point A, right underneath it, is that the angle is 0, right? We already did the calculation for this. I'm going to do the calculation, but we already did it. So if you guys go over here, you're going to find 0.88. I'm going to do it one time and then 949 times cosine 0 to the power 3 raised to the power 10 to the power 2. That will get you a healthy 8.25. We could have identical, so what I wrote here is identical to from fixture 2 to point B. Can you guys read my handwriting here? You don't really need to do that. That one that I did in red, you do not need to do it. On the test, Darren, you're going to say, you have the option, either do it, which you shouldn't, or say, Chad, this location is this identical to from fixture 2 to point B, because we already did it. And you just put the answer 8.25, done. Can I have thumbs up, Chad? We understand. If it's identical, but I want you to write it's symmetrical. Because of the symmetrical, the calculation will be identical. Because symmetrical between the triangles. If you guys look at these posts here, each one of them is a pole. Right underneath the post, the calculation from the fixture right to the top of it is going to be the same, right? Any comments, any questions? Jamie, my friend? No? Let's go to fixture 2. Now, from 2 at point A, from 2 at point A, also symmetrical. Anybody can tell me the answer before I start it, right? 3 point, well, I'm going to do the calculation here just because, but it's really symmetrical. So let's look at the angle. The angle, guys, is 10 over 10 equal 1. I'm repeating myself here. 10 inverse 1 equal 45 degree. Then I will use the calculation. I really don't need to. 0.88 times the foot candle at 45. We just found it is 1039 times cosine 45 raised to the power 3. Divide this by the mounting height of 10 to the power 2. And if you guys did this, you're going to find foot candle equal to 3.23. And I really don't need to do this. Symmetrical. Right? Do I need to do this calculation? Symmetrical. Can you guys see symmetrical between them? symmetrical. Any comments, any questions, guys? So no need to do this calculation. These two calculations, I just did them because. No need to do them. Questions? Cool? Everybody's okay with that one? Right? So let's go to the last point. The last point, now contribution from fixture 3 at point A. Let me remind you, gentlemen, that fixture 3, just if you draw the line here a little bit, this was fixture 3 here, fixture 2 is here, and fixture 1 is here, right? And can you guys see the extent in between them? Now I'm going from 3 all the way to point A. From 3 all the way to point A. Can you guys see that? Now that's different. That's slightly different. Okay. Because of this, what is tan Q3? What's tan Q3? The opposite over the adjacent. What's the opposite? These are distances. What's the opposite? 20 over what's the adjacent? 10. So that will give you what? 2. Now then you have to go tan inverse 2. What would that give you? Tan inverse 2? 63. 63. Okay. Did you guys come up with 63? Tan inverse? Okay. Now, you take this is the tan. Now you're going to take the 63 degree to fig 5.3 at page 50. If you guys go there, do you have a 63? What do you do? Kerry, what did you say? You go up. Okay? I want you to go up. If you can't find it, not really. Here's what I would like you guys on the test. Go to the closest, not up. Go to the closest. Okay, so I have 63. I can either go to 55 or 62. Which one is the closest to 63? 65. Did you guys hear me? Please write yourself a note. Go to the closest. What's the closest? So then 65 degree from 65 closest. The closest is 63. From 65, you're going to find 78 degree. 65, no, not 78 degree. 780. 780 lumens. Now, the old days, Darren, they used to interpolation. Anybody have ever heard of interpolation? Do you know what interpolation is? If you have a value between two values on the x and another value between two values on the y, you can, by knowing the two values, one above, one below on the x, one above, one below on the y, you can actually find the value in between them, interpolation. I'm going to save you the hassle of doing interpolation, basically prediction. You can predict what this what this point is. I'm going to save you the hassle because we don't really care too much at this time unless you become a certified lighting designer. And for us, where we're going to go, Aaron? Not up. Up is wrong. Go to the closest. To the closest to give you better. So actually, our value is different than this. If you do interpolation, but the interpolation is good enough. Rest is history. So you're going to plug 0.88, multiply this one by 780, multiply this one by cosine. Now when I put the cosine, here's what I do. I put the cosine 63. That's me. I don't put the cosine of 65. I put the cosine 63 because the actual angle is what? 63 that we're measuring it. So it gets you closer at least to the truth. And then divide by 10 to the power 2. And that will give you a healthy 0.64 foot candle. 0.64 foot candle.
That'll be cube there, not square.
This one is going to be cube. Absolutely. Thank you. This one is going to be cube. Yeah, the cosine is always cube. The height is squared, the cosine is cubed. Any comments, any questions? That's as ugly as it gets. Yes, sir.
I mean, is it just a calculator thing, or I mean, like, why did it come up as being 63 degrees?
Why did it what?
Why did it come up as being an angle of 63 degrees in the first place? If you have a side that's 20 and a side that's 10, it's automatically going to be a 30-degree angle and a 60-degree angle. That would be a right triangle.
I think you're confused. This is 20 divided by 1, give you angle of 63. No, not 30, this is not 30, 60. What's the angle of 30? It's 2/3. Which one is give you 2/3 sine? No, this is not a 3, this is not 30, 90, 30, 60 triangle, right? This particular one is not.
I figured it would be if it was, if you had one
Twice?
side that was equal.
No, I don't think so, based on the geometry.
I don't know, maybe I need to go back to 8th grade. I don't remember.
Yeah, no, I see your point is. No, this angle is 63 based on the tan.
Okay.
Based on the tan, right? We did the tan right. Take the opposite over the adjacent should be 63, not 60. But I see your point where you can sometimes you have a 60 here, this is 90, then this one will be what?
Yeah, I automatically assumed that you had one side like that was twice the other, that was a 30, 60.
I don't think so, no. What is that? We can do the math on that one, but okay, we're not going to make it trig. We'll get to the trig. I know we did right based on the thing. Okay, so this is the contribution at point 3. The total contribution at all at point A, guys, all the contribution at point A that you can imagine at point A, where we here we got this one. So we're going to go at point A. We have 8.35 plus 3.23 plus 0.64, and that will get you a healthy 12.22. As expected, the fixtures or the point in the parentheses, guys, or at the end, they will have this light, so that will be 12.22. Okay, now here's the fun stuff. Doing the calculation at point C, you don't have to, right? You don't have to do it at point C, because I'm going to take you back to the trig. If you excuse me, Jeff, my friend, I'm going to take you all the way. Can you guys see that at point A and at point C is identical, right? So the contribution from 3 to C is exactly like from 1 to 8. The contribution from 2 to C is exactly as a contribution from 2 to 8, right? Identical. And the contribution from 1 to 3 is identical to the contribution from 3 to 8. Can I have thumbs up, Chad? We fully understand the trig and the symmetrical in this equation. So do I need to repeat the calculation for C, or should I just write the total contribution from all of them? Write it down. So when it comes to C, we're not going to go. So C basically will be the same as A. Exactly the same steps that we did at A. Same steps. But to save you and me a hassle, this particular one will be also a 12.22. Total foot candle at point C is this amount because of symmetrical triangles. Do I need to go the calculation at C? Done. Done deal. Any comments, any questions? Any comments? Is that hard? Easy? Now imagine doing this calculation in the parking lot for every single point in your parking lot. Thanks God for visual. Cool. In the old days, guys, they used to do it a couple of certain calculation by hand. So we don't do it. Why do we do it then by hand? Joe, my friend, 2 things. First, to torture you guys. Second is to get you to appreciate and understand the calculation behind it, right? Now, when you use visual, you know how visual is doing this calculation. I think hopefully it sticks it better here. 5 minutes break. I'm going to continue with more lighting. Thank you. Yep. Okay. Any comments, guys? Any questions about this? So, really, on the test, on the final, I'm going to give you a problem like this, and you're supposed, guys, to calculate 3 points. Calculation, find the foot candle contribution from 3 points. Okay, so we got that one. Here's a new one. Now, this one, I would like you guys to draw that. Now, everything that we calculated was on a horizontal, right? Horizontal plane. Or plane. So now, what happens if you want to do it on a vertical surface? A vertical surface versus a horizontal. One more time. If the formula that I gave you guys does the calculation on a horizontal surface, right in front of you, Zach, right on the desk. Now, what happened if I have the Mona Lisa and I want to shoot light on a vertical? You guys have done it with visual. Remember how we did in a conference room 2 walls, and we assigned a calculation zone at the wall, and we did calculation, right? And I assume you guys will print they should show calculation on the 2 walls, near calculation zone. This is how you do it. If you're going to do a calculation on, we've just started, guys. So if you're going to do a calculation on a wall, cool. So we can do calculation on a wall, or we can do calculation on the floor. Can I have thumbs up, chat, that this formula is for calculating on a wall? Okay, so what's the difference? The difference is you take the CP, the same thing, sine Q, divided by the distance squared.
Is this still part of chapter 5?
This is part of chapter 5 still. We're still in chapter 5. We are in chapter 5. I don't have it with you. I didn't give it to you guys. I did not give you this one. Can you guys draw that one? I did not give you, sorry, I should have made a copy of that for you. Huh? So this is example. I'll go over it in a second here. So here's what I have. I have a fixture, Kerry. The fixture is 10 feet high, and the fixture is shooting light on a wall. Of course, the wall is also 10 feet high for the most part. And I need, the distance between the fixture and the wall is how many feet? 4 feet between the fixture and the wall, 4 feet. So I have a fixture on a 10-foot high pole. It's shooting light on a wall. The wall opposite is going to be for the most part 10 feet, right? And that the wall is 4 feet, or the fixture is 4 feet away from the wall. Cool. Here's the 4 feet. And my question for you is, I would like you to do the calculation at point 1 right here, opposite. Can you see straight opposite where the fixture is, at the same level? And I want you to do a calculation at point 2, right? Which is basically 5 feet down, right in the middle of the center of that wall. If I ask you to do a calculation at any point on the wall, you should be able to. I just picked 2 points for the sake of the calculation, and I would like you guys to do a calculation from 1 fixture. Now, if I ask you from 10 fixtures, would you be able to do it? Same thing, contribution from 10 fixture. For vertical calculation, guys, I'm going to only do it contribution from 1 fixture. Okay, here's the formula.
Is that light 10 feet high?
I'm sorry?
Is that light 10 feet high?
This is 10 foot high, yep. The light from here to here is 10 foot high. Yep, 10 foot high. 5 is this little area here. From here to here. It's 5. Cool. So I need to find 2 angles. Angle number 1, my friends, is shooting this way, and angle number 2 shooting the other way. So here's the formula that you, any question about the graphic? I have a fixture 10 foot high, shooting lights at a wall. The wall and the fixture are 4 feet apart, and I need to do the calculation at point 1, which is the 10 foot, and at point 2, which is 5 feet. Cool? 2 calculations I need to do. Here's the most important thing. With the formula that we use, guys, this is the mother of the formula that you guys were using anyway. we use CP sine Q, no cube, no square, nothing. Multiplied by the guard factor again, divided by the distance, d squared. Now you can flip this formula and make it by the height of the fixture. For the vertical calculation, I care less about flipping it and making it based on the height. I'm basing it on the distance. And d, the distance d is this distance right here. Can you guys see that? D. This is the distance. The distance between the fixture and the point of calculation. Between the fixture and the point of calculation. Okay? One more time. CP, candela power, sine the angle. The angle is that, this is the angle that you make with the vertical, right? Here's my angle. Angle 1 from here to here is 90. Can you guys see that? Angle at point 1, the angle is 90. At point 2, I need to find it. And D is the distance between the fixture and the point that I need to do the calculation at. This is the D, or this is D, depending which point I want to do the calculation at. Everybody got the formula? Understood what the meaning are? Okay, now let's go do the calculation. Now I need to do the calculation first at point 1. At point 1, what's the angle at point 1? What is my angle at point 1? The angle right here. Here's point 1. So the angle is basically from here to here, because the ray is going to be going this way. The angle is 90. Anybody disagree with that? 90 degree, right? Now if you go to, again, Fig 5.3, page 50, and what is the angle at 90? The contribution at 90 degree. Do we have a 90? We have a 98. Everybody got that one? So at the contribution at 90 degree is 8. The contribution at 90 degree is, this is 8. 8, this is 8. The contribution, 8 foot candle, not, 8 candela. 8 candela. Cool? Any question where I came up with the 8? No? Directly from the 90, this big. Then plug in the numbers. Let's plug the numbers. I have a guarding factor of 0.88, the same guarding factor that we were using. Multiply it by candela power of 8, multiplied by sine 90, no raised to the power nothing, divided by the distance squared. Now the distance squared, what's the distance from here to here? Anybody can, what's the distance directly up? 4, right? It's easy, 4 squared. So d squared, 4 squared. If you do the math in this boy, you're going to get a 0.44 foot candle. 0.44 foot candle. Piece of cake. 0.44 foot candle. On a test, you're going to grab this formula with you. If I ask you for a foot candle on the wall, plug it into. If I ask you foot candle on the floor, you're going to use the floor. Make sense?
Is that FC 1?
This FCV for vertical. The reason why I put the FCV here, guys, is for vertical, because we're doing foot candle for vertical. The one that we were just doing before, it's the horizontal. Doing calculation of horizontal versus vertical. Okay? All right, so I found the angle. Everybody understand how we found the Q90? That's the angle that you make with the vertical. From there, we got 8 candela power, which is lumens. Plug it into the formula. Where's the 0.88? Guard factor given.
That could always be different.
Yes, I'll have to give it to you on the test. I could be 0.9, but it has to be given. And then you can assume it's 0.88 if you don't know, but, and this is your foot candle. Not a whole lot of foot candle. Not a whole lot of foot candle. Okay. Any question, guys, about finding the calculation at point 1? Is that piece of cake? Piece of cake?
That was, obviously, different situation, different formula. What is the theory behind, like the formula for the other one was you cube whatever's on the top?
You know what? The good point. Behind why this is D and the other one is height, it's string. You can go flip the D and make it in height here, and do the calculation. Change the D. You know how the hypotenuse, right? It's a right angle triangle. You can play with the trig to replace the D with the height. Really, the first one we replace the D with the height using the trig.
Okay.
That's all.
And it's
So-
simply because you're using distance instead of height that you're not cubing what's on the top.
Yes, because of the trig when you flip it.
Okay.
Yeah, guys, the whole idea. Can I get you for a second here? When you find a foot candle, the general idea of finding foot candle is the lumens over area. That's it. Lumens over area. That's the good foot candle, right? But when you get outside, it becomes lumens over area with the factor of the distance between them. Then you start playing with the trig and so forth. Okay, let's go to at point 2. At point 2, my friends, let's do that at point 2. Now, at point 2, I need the tan of Q2. Can you guys see Q2? What's tan of a Q2? Tan of a Q2, everybody can see tan of a Q2. Here's a Q2. Tan is opposite over adjacent. The opposite is 4. The adjacent is halfway through, right? What's the adjacent? Halfway through 5. 10 is what? 5. So 45. 4 over 5. So that will get me 4 over 5. Everybody knows where the 4 came? 4 is this side. 5 is half of 10. Because I'm picking this particular point right in the center. 4 over 5. That'll give me 0.8. 0.8. Actually, I drew a triangle here. So here's the 4 or 5 guys in the distance. We'll talk about this in a second here when we get into the trig. Okay, so 0.8. So tan inverse 0.8 is what? Tan inverse 0.8 equal. If you go tan inverse 0.8, you are end up with 90 with 39 degree. 39 degree. Okay. 39 degree. Now 39 degree. That's 39 degree. So this one, guys, you're gonna take this boy to Fig 5.3, page 50. Because I don't have 39, I need to go to the closest. Can anybody tell me what's the closest? What did you guys come up with the closest? 35 degree. So from there, I need to go to the closest, 35, because I don't have it. Then I continue with the calculation based on 35 degree. Take this one, the same thing, to Fig 5.3, page 50. And that will get me, wow, look at that. You don't want to do that. Okay, so if you go there, that will get you from there 105. We're going to go to 1059. Anybody came up with something different? 1059 foot lumens. 1049. So I went to the closest. Can you guys write yourself closest here, please? You go to the closest. You go to the closest angle. Questions? How to find the angle and the candela power from that chart? So on the test, Aaron, my friend, if I don't give you that chart, there is no way you can calculate it. If I don't give you the chart that has all the foot candle angles, good luck. Now in visual, all these are loaded as an IES file. All this information is loaded out as an IES file. That's why we're just picking IES files before we work on them. Okay, now let's go do the calculation. So I know what the angle is. Let's go do the calculation. So I'm going to have a 0.88, multiply this one by 1059, multiply this one by sine 39, divide this by 6.4, 6.4 square. Where the heck did I get 6.4 square? The distance. The distance, here's a triangle. I need to find D. D, guys, is the distance. Here's how we find the distance. D equal square root of 4 squared plus 5 squared. If I did that right, this should get you 6.4. Can you guys check that? You need to find the distance. So foot candle 2 equal 14.3. 14.3. One more time. You need to find the distance. To find the distance, here's the angle that we were just talking about, guys. Remember that angle? The angle was 39. Here's my 39 angle. One way of finding the distance is to use the Pythagorean theory and square the two sides, add them up, take the square root of them. That will give you the hypotenuse, right? Any comments, any questions? Any comments, any questions? Any comments, any questions? That's as ugly as it gets in terms of calculating on a vertical. Now, if I ask, whom am I going to pick on? Zach. If I ask my friend Zach to go and do the calculation at this point, Zach, and this point is 2 feet away from the finished floor here. So I have 10. So this is 2. You can find, right? You do your math, and you can easily find the calculation and the angle at any point here. I have to give you the height, right? If I say 2, then you make a triangle. This side would be 8. This side would be 4, and you do the calculation. Can I have thumbs up, Chad? We fully understand how to do the calculation on a vertical and a horizontal surface. Cool. Let's flip into the floodlight since you guys are up and running here. Let's do a floodlight. The last one is going to be the floodlight. One more time. Any question? I'm going to review with you guys. Here's the one that we use for vertical. You can see it. Let's go back all the way to the formula that we use. Here's the formula that we use for horizontal calculation. And like you said, this mounting height is actually derived from the trig. Typically, this was d squared, but we manipulate the trig with the cosine to get us the mounting height. Okay, we could have done that in the vertical, but I don't want to do it. Okay, so that's basically all what we have here. Any comments, guys? Any questions about vertical and horizontal calculation? If my second thing for you guys, if I have another fixture, if I want to complicate it, and I put another fixture right here, and that fixture at 2 feet away, and ask you guys to calculate it. So first you do the calculation at 4 feet from fixture 1, then the calculation at 2 feet from fixture 2, and you add them up, right? No rocket science. Huh? You add them up. Okay. You add them up. Okay. Okay, so let's go and I'm going to minimize this, and I'm going to go to another topic, guys, so we know how to do calculation. I'm going to go to this one. Okay, before we leave, chapter 5, guys, talk about two things. Doing point-to-point calculation from an outside, these are for outside fixtures, point-to-point calculation on the horizontal surface as well as on the vertical surface. And you guys assured me that you know how to do it in visual, and you know how to do it by hand. Jeff, right? Am I right to assume that? No? Okay. Now let's do floodlights. Floodlights. What's a floodlight? A floodlight, guys, these are big lights used in stadiums and all this good stuff to give you huge amount of lumens. You've seen them all over, right? Big, huge amount of lumens. Okay, basic floodlight calculation. We haven't done floodlight in visual. You can do floodlight in visual. You can grab them, do floodlight in visual. We're going to touch on it with one formula, and I'm going to let it go. So here's the situation that you guys have. You have it right in front of you, right? I gave you that sheet. I have, everybody knows that floodlights, typically they are mounted very high, 30, 40 feet, 50 feet, and they're shooting lights all over. Stadiums, playgrounds, and all this good stuff. Here's my situation. I do have a floodlight fixture, It's outdoor, mounted at 30 foot, right? This fixture, a few things about this fixture before we move on. We'll get to the lumens in a second. Do I have the lumens about this fixture? I do. I should have the lumens about this fixture. Okay, lumens. I'll get you the lumens, guys, in a second. I'll get you the lumens in the next slide about this fixture. But the lumens about this fixture is given as 27,000 lumens coming out of it. 20. When it comes to the floodlights, guys, they start talking about thousands of lumens instead of 2, 1, 2. This one's 3,000. In the floodlight, it becomes thousands. 25, 15,000, 25,000. Okay, I have one floodlight mounted at 30 foot. The area that I want to lit out of this floodlight is, later on I'm going to tell you guys, it's going to be a, what is it, 40 by 40 area. Okay, so when we have a floodlight, a couple of things you need to do. Here's the formula that they use for a floodlight. Floodlight, it calculates the average, not the point to point. Everybody understand the difference between what we're doing? Point to point, this is average. Number of lights, so how many heads do you have on this floodlight? How many lights? Okay. Lumens, how many lumens coming out of each head? Multiplied by coefficient CU. CU, guys, is coefficient of utilization. How efficient the design of this fixture is, given a factor. And then CPU is coefficient to beam utilization. Beam utilization, because these are floodlight, they can adjust them, right? They can tilt them, adjust them to get you the best performance of them. That will affect, that's a factor. They call it coefficient to beam utilization. You have to understand, coefficient to beam utilization. Then LLD, lamp lumen depreciation factor, how often this lamp depreciates, and lumen dirt depreciation factor, how often do you clean it? As far as you guys are concerned, all these LLD and LDD, these are light loss factors. Remember, we use them, they're called light loss factors. Light loss factors because of depreciation in the lumens, and also because of the dirt, and also because of a bunch of other things. Divided by what? The area that you're supposed to lift. Can I have thumbs up, Chen? We fully understand that formula. On the test, if I give you, when I give you a flood calculation, you're going to grab this formula, put it in front of you, do the calculation. I don't expect you guys to memorize all this stuff. If you do, great. If you don't, grab the formula, put it in front of you. One more time, I can't emphasize, this is calculating average foot candle, not point to point. So if I ask you, what is the foot candle at 0.15 away from the floodlight? Good luck. You can't find it. I can tell you what the average is, but not what point. Okay, I need a thumbs up, Chad, to understand that this is, we understand what this formula does. Floodlights. Cool? Can you guys see that red here? This is the red. This is how the coefficient to beam utilization, that's the kind of how they adjust it. This is where we're going to shoot, and they go 10 or 20 feet, and they do the calculation for beam utilization. We'll talk about this in a second. Any comments, any question about these factors? Any comments, any questions? Yes, no? Comments, questions about this factor? Okay, so do me a favor. Go, guys, to chapter 6, please. Go to chapter 6. And this is basically, that's what they're using. It's 3-page chapter. Very easy, very straightforward to use. I want you in page 59. Can you guys see the angle and candela power? An angle candela power for this fixture, floodlight. There's also right next to it. Can you guys see that little graphic here? That little graphic is called beam utilization, the beam utilization factor, or coefficient to beam utilization factor. It tells you how much out of these tons of light is going to reach the ground because it's too high. Long story short, before I move, guys, to the next slide, any question about these factors? Everybody understand what the formula is? One more time. N, number of lumens, number of fixtures on the head. Lumen, how many lumens coming out of these big fat fixtures? CPU is how do you aim, the coefficient to beam utilization, the coefficient to aiming this fixture. Coefficient CU, coefficient of utilization, how efficient the fixture is. Think of it as the efficiency of the fixture. light loss, lamp lumen depreciation factor, how much you lose out of your lumens over the life of the fixture, and LDD is called lumen direct depreciation factor. For those of you who were here when we did chapter 4, guys, we did LLD and LDD and a bunch of other factors. Okay? Any comments, any questions? Let's go to the next, do a calculation. Okay, so here's my, the formula that they use, guys, for this. You might have to write this. Lumens hitting the surface divided by lumens emitted from the luminaire. The coefficient of utilization is divided as how many lumens get out of the fixture divided by how many lumens hit the surface, and they give it a factor. So for example, if I want to aim at your head here, this will be the perfect, for example, to get most of the light from the light into your head. If I go up, that factor will be worse or down. Does that make sense? The factor that gets you the best performance of the fixture. They define it as how many lumens got out of the fixture versus how many lumens hit Brian's head as I point that light at his head when he's playing football or any other game. Okay? So that's just a definition. Just a definition. Now let's go do an example. Now that you guys know, let me know when I can flip. Here's my definition. Okay. This is exactly like the graphic that you guys are dealing with. Let me explain this before you go and start working on it. I bought a 250 watt high pressure sodium. Cool. I mounted the high pressure sodium in sport arena, outdoor sport arena, mounted at 30 foot or higher, okay, 30 foot. This, by the manufacturer told me that this fixture will be giving 27,500 lumens. A lot of lumens. That's why they call them floodlight, guys. Tons of lumens. A lumen means light. Okay, so it's Brian, it's like this one above your head. The lamp is giving 3,000 lumens. Imagine $3,000 versus $27,500. That's really how it compares to each other. Much better light. The coefficient of utilization of the fixture from the manufacturer is given at 80%. They're telling us it's 80% coefficient of utilization. Okay? The area that I need to lift in this sport arena is 40 by 40. I have a 40 by 40 area I need to lift. Lamp lumen depreciation factor given as 0.8. Lamp dirt with the lamp dirt depreciation or dirt, the dirt factor is 0.7. All these are given information. Everything here is given information. Okay? Everything is given information. And here's the graphic. The coefficient of beam utilization, I'm going to aim 10% above and 10% below that line that you're looking at. If you guys go to Fig 6.1, which is that one right here that I'm looking at. If you go here and you go 10% above, 10% below, it will give you a coefficient to beam utilization of this fixture of 0.2. Coefficient of 0.2. Here's how it goes. You go 10 above, 10 below, 10 below, 10 above, and you cut it, and it will reference. Can you guys see if you go across, it will get you 0.2. The good news is I will give you the coefficient of utilization. But how do you calculate the coefficient of utilization? Find it from the graph. I have to give you how many I want to, when I focus this fixture, I will focus it at this point, and I want to go 10 above and 10 below to give it the best performance. Right? If you put, here's the focus, I need the focus to be between 10 above and 10 below that aiming point. That will give you give me a coefficient to beam utilization 0.2. Cool. This graphic is represent Fig 6.1, guys. So you come, here's the minus 10. You cross it. It should this curve should go a little bit higher. As a matter of fact, it should something like this, and this should be something like this. Okay. So and then when they cross it, you can see where they cross. Can you guys see where they cross? When they cross here, This is where you get the point. Can you guys see the point 2? That's where you get your point 2. Right in here. And I'm trying to graph. You guys have it in yours. So this is where you get point 2. Give or take. This is my point 2. Cool? Based on the aiming that I have. The good news is for you is I will give you the coefficient of beam realization on the fixture. You don't have to do that. Any comments, any questions? Any comments, any questions? So I have a fixture, 250 watt high pressure sodium. It's shooting 27,500 lumens. The efficiency of this fixture or coefficient of utilization based on the design is given by manufacturer as 80%. The area that I need to lit is 40 by 40, so there's a 40 by 40 area here I want to lit. And the lumen depreciation is 0.8. The dirt factor is 0.7. It's dirty place. They don't clean them often, right? That's what 0.7 means, dirt factor.
CCD or
LDD, dirt depreciation factor. We just wrote it here. Luminaire dirt depreciation, LDD. I forget them most of the time too. LDD. This is an L, not a C, even though it looks like a C. LDD 0.7. Okay. The rest is history. Look how easy they are. Now, how many fixtures? Here's the formula. The number of fixtures multiplied by the lumens, multiplied by the coefficient of beam utilization, multiplied by the coefficient of utilization, lumen depreciation factor, luminaire dirt factor, divided by the area. Cool? Now, how hard that is. So how many fixtures do I have, Jamie? 1. What's the lumen coming out of this gigantic floodlight? Almost 28,000, right? 27,500. What's the coefficient of beam utilization based on given to you here? 0.2. What's the the lumen depreciation factor? 0.8. What's the dirt factor? 0.7. What did we forget here? 0.8.
Oh,
See the coefficient of utilization, the lumen depreciation, and the dirt, as well as the area is 40 by 40. That will get you a foot candle of 1.5 for foot candle.
all those will be given to us?
Everything is going to be given to you. Everything.
Even that point 2.
Yes. Because I don't want your point to it. Yeah. Really, everything is going to be given to you. The reason why I did this one, just to show you how they find it, you have to give them where do you want to aim it and how higher 10 degrees above and 10 degrees below is your focus point from that center point. And that will give you a point 2. So all these factors will be given to you. Really not rocket science when you. But do you guys understand why they use a floodlight different? Because they're huge, they're mounted high, they're huge, and they give you tons of lumens. They give you tons of lumens. And we have this one for one fixture. If there's multiple fixtures, then the calculation completely, you go to visual. Will you? Don't ask me about it. You're going to go to visual. I'm not going to go to chapter 7. Any comments, any questions? Any comments, guys? Any questions? So to summarize, my friends, chapter 5 will do an outdoor foot candle calculation point to point, they call it, because you can find it the actual point for one fixture or multiple fixture at one location or multiple locations on a horizontal surface or a vertical surface. That was chapter 4. Chapter 5 and chapter 4. Chapter 6 gets you a floodlight. What's the difference? The floodlight, if you can see, the mounting height is much higher, as well as the lumens coming out of the fixture is much more lumens coming out of the fixture, right? So the smarter than chat came up with a different formula to give you the calculation. The good news, guys, all these formulas have been tweaked into visual and adjusted. If you remember, Darren, when you put the height of the fixture at the higher height, that curve that comes with the fixture that represent the foot candle, it changes shape based on the height. Because based on the height, you can go get more foot candle or less foot candle. Okay? Any comments? Any questions? Any comments? Any questions? Yes, sir.
Doesn't visual also calculate like the like in a room you have like a reflection like back
Thank
to the
you.
walls and things like
Very
that?
good point. Brian said, Chad, you're a knucklehead. He didn't say it, but I'm saying it.
Not saying
What
it.
happened to the reflection from the floor and the ceilings and the walls? Okay? I want to remind you guys what we have done calculation so far is what? Outdoor. Outdoor. Outdoor, there are no walls or ceilings. There is floor, but you can neglect the reflection from the parking lot floor. What we did in chapter 5, 4, 5, and 6, everything is outdoor. For one reason, we have not done any single calculation indoor. Because when that will be chapter, that will be a couple of other chapters. That will be floodlight calculations. We did that. That will be chapter 8. No, chapter, not roadway. All the way to chapter 10, as a matter of fact. Yeah, chapter 10. When we hit chapter 10, gentlemen, this is when we start doing calculation inside the building. Then I have to give you the coefficient of utilization for the fixture based on the location, as well as the reflection from the ceiling and the floor and so forth. Good, very good point. So far, we're doing outside calculation by hand. Can I have thumbs up, Chad? Cool. Okay. Any comments, any questions? Is that good enough? Cool. That's all I have for you guys. Expectation from the A, B, and C students is to finish their lighting, layout, circuiting, and labeled by Friday, printed it, give it to your friend Chip. Cool. Tomorrow I have 2 more chapters in the red book for you, and we will be on track. Thank you. Homework for these guys, just a quick reminder. Homework 5 and 6, and are due next week on Monday, because I'm going to give you the answers for the homework, because the test is going to be, test and lighting is going to be 2 parts. One calculation like I'm doing, and the other one will be essay and fill in the blank from the question at the end of every chapter. Cool? I remind you guys on Friday also, I would like to check your homework, make sure you're up to date in homework as of Friday. Everything that's not on the board should be submitted by this Friday too. So, all right, thank you.
Can the color of a wall determine how much light it reflects?
Yes, absolutely. 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 We're coming to this in chapter 10. You'll see when we reach it.